my name is Darshan. I'm an online tutor of math and physics. This is in continuation to the optimization questions which we were doing. So let's get started. A rectangular bird sanctuary with one side along a straight river is to be considered so that it contains 8 kilometers square of area. So given condition, find the dimensions of the rectangle to minimize the amount of fence required necessary to enclose the remaining three sides. Optimization function. So the situation is something like this. We have a rectangular, uh, you know, uh, 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 a sanctuary which is surrounded with one side with the water. So no fencing is required, and the other three sides require fencing. Condition is the area is 8, xy is 8, and x plus y, which is the fencing, something which we have to optimize. So this is the optimization function. So all we have to do is, of course, replace y in terms of x or x in terms of y. I would like to replace y. So it will become 2x plus, from here y is equal to 8 over x. So it will become 8 over x. So a function can be written as 2x plus 8x raised to minus 1. So f prime will be 2 minus 8x raised to minus 2. So f prime will be 2 minus 8 over x square. So f prime should be equal to 0, which means that 2 minus 8 over x square should be 0, which means that 2 should be equal to 8 over x square, which means that x square should be equal to 8 over 2, cross multiplication, which means that x square should be 4, which means that x should be plus minus 2, but I won't write minus because x cannot be negative in this case because that's the length of the sanctuary. I have to make sure that at 2 I'm getting a local minima. So I'm just gonna make a sign chart over here at 2. So at 2, f prime is over here. Anything less than 2, maybe 1. So 8 over 1 is 8. 2 minus 8 is negative, so this is negative. I think more than 2, maybe 3. 3 square is 9. 8 over 9 is less than 1, so that's 2 minus less than 1 is positive. Indeed, it is a local minima. And we need to find the dimension, so we just got the value of x. It is 2. And the value of y is 8 over x, so 8 over 2 is 4. So y is 4. So the dimensions are 2 units and 4 units of the bird sanctuary to have a minimum fencing. Let's try the next question. A jewelry box with a square base is to be built with copper plated sides, nickel plated bottom and top, and a volume of 40. So right off the bat, volume is given to us. Something which is given is 40. If the nickel costs $2 per centimeter square, copper costs $1 per centimeter square, so find the dimensions of the box to minimize the cost of the material. Cost is the optimization function. So first let's make this jewelry box because that's like a cuboid. This is how the box looks like. The dimensions are x and x. Why x and x? Why not x and y? Because it's a square base. So a square means both the sides are equal, and its height is y. Its height is y. Okay, so the volume is going to be length times width times height, which is going to be x times y, which is x square y is equal to 40. That's equation number 1. And if nickel plating costs $2 per centimeter square, and nickel is where? Nickel is at the bottom and top. So what is the bottom area? X square. Top area? X square. So what is the area of the top plus bottom? X square plus x square, which is 2x square. Okay. And what is the area of the remaining sides? Because that's where copper is. So area of the remaining sides is the sides is going to be, I think it will be same, right? It's just a rectangle which is xy, 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 xy. So it's 4xy. Okay. So what is the cost now? The cost of the top plus bottom is the cost of the top plus bottom, and the top plus bottom is what? Nickel. the cost of nickel is $2. So the cost will become 4x squared because 2 times just 2x squared. And for the sides, the cost is going to be $1 per centimeter. So it's just 4xy. So the optimization function is 4x squared plus 4xy. And obviously I don't want this y with me, so that I'm going to use equation number 1 and replace this y over here. So it's going to look like 4x squared plus 4x times 40 over x squared, because from here y is 40 over x squared. Okay, so I'm going to continue my work over here. So the function f is going to look like 4x squared plus one of the x is gone, and this will become 160 over x. So it will become 4x squared plus 160 x raised to minus 1. That is the function. So f prime will be 8x minus 160 x raised to minus 2. So f prime is going to be 0 for the critical point. So 8x minus 160 over x squared should be equal to 0, which means that 8 is taken as, in fact, yeah, let's take a common denominator of x squared. So it will become 8x cubed minus 160 is equal to 0. Okay, all right. Let's try to make some space over here. Okay. So this is going to look like, so 8x cubed minus 160 should be 0, because x is equal to 0 will make it undefined, and it won't make any sense because x equal to 0 is like there's no box. So 8x cubed should be equal to 160, which means that x cube is equal to 20, which means that x is somewhere around 2.7. And is this giving a global local max and local min? So let's find out. 2.7. This is going to be less than 2.7, maybe 1. So 1 is going to make this negative, and 3 is going to make it positive. So this is indeed a minima. That's what we wanted, minimum cost. So they need the dimension, so we got the dimension. X is somewhere around this and y will be somewhere around. I'm just going to plug this in over here. So that's going to look like 2.7 square and 40 divided by answer, about 5.5. So these are the dimensions of the box that's going to minimize the cost of it. Hope this makes sense. In the next video, we're going to talk about a last question on optimization. I'll see you there. Bye-bye.